Hello and welcome to my channel. In this math video tutorials, I want to solve this partial fraction. I want to resolve this expression to a partial fraction. And the first way you want to go about it is to make sure you have this quadratic function to look like a linear factor. So we have 2x squared minus 7 all over x plus 1. So how can we make this to look like a linear factor? You want to think of two factors of 6, and then when you multiply those factors you will have minus 6, and when you add them up you have minus 1. So if I have 6, the factor of 6 will have to be 2 and 3. So what sign should I add so that when I multiply them it gives minus 6, when I add it gives 1? So I would think of positive 2 and minus 3, because 2 times minus 3, that will be minus 6, and 2 minus 3, that will be minus 1. So I will have to incorporate it like this. I will have x into x plus 2 minus 3 into x plus 2. So I have factorized this. These are the factors 2 and minus 3. So the best way to arrange this is to say that 2x squared minus 7 all over x plus 1. You could put this in a bracket, and then we have x minus 3 outside. You could also consider x minus 3. Then because x plus 2 are common, then you want to place it here, and the whole of this will be equal to, so we are having 1, 2, 3, three different denominators, like three different terms here, first, second, and third. So it means that I will have the first one like this, I will also have the second one like this, plus the third one like this. So I will assign the first one as x plus 1, the second one as x minus 3, and the third one as x plus 2. Alright, so then I will have to assign a variable or a constant to them, a, b, and c, because they are all linear factor. All right, so if that is well articulated, so we want to make sure the whole of this expression or the equation you have in here appear in the linear form. So one way to do that is to multiply. I have a series of ways I can go about this, but the easiest way is to multiply the whole of this equation by the whole of this denominator you're having. Alternatively, you can just have it to be like this: 2x squared minus 7 all over x plus 1 into x minus 3 into x plus 2. This will be equals, of course you know that the LCM, this is another way you can do it. LCM of these denominators are everything you are having at the denominator: x plus 1 into x minus 3 into x plus 2. All right, so what is the next step we need to follow? If this goes into this expression, meaning that this will cancel out with this, x plus 1 will cancel out with x plus 1, left alone with this. So these two terms will multiply by a, so we have a into x minus 3 into x plus 2 plus, okay, we omitted sign here, we have them to be positive sign. Please do not forget that. So you can see that we've separated this into partial fractions. All right, this will cancel out with this, left alone with b and the rest of this. So I have b into x plus 1 into x plus 2. And lastly, we will have this to cancel this, so we have c to multiply x plus 1 and also x minus 3. All right, so at that point, if you multiply the whole of this equation by this denominator, you can see we have similar denominator. So if you multiply the whole of this by this denominator and also multiply the whole of this by this denominator, that will cancel out. This will cancel out with that, and this will also cancel out. So easier way I want to do this is to cancel this like this and cancel this like this, so that you have 2x squared minus 7 equal to a into x minus 3 into x plus 2 plus b into x plus 1 into x plus 2 plus c into x plus 1 into x minus 3. So what is the method that we are going to use in order for us to get this value of a, b, and c? We want to know what values this a, b, and c will hold. So we have two methods. You can use the cover-up method, or you can use the method called the comparing of coefficients. But I think the cover-up method or assumption method can work here. So how do we assume? If you want to eliminate this a, you look into this b and c, the properties in this b and c, which one of them is common? And then I notice that x plus 1 is common to both sides of this. So since x plus 1 is common, what can you think of to replace this x to make the whole of this to be 0? So I can say when x is equal to minus 1, keep in mind we want to look for a, so we want to make sure this 2 disappears. So if I substitute minus 1 in place of x, the whole of this becomes 0, and 0 affecting everything here becomes 0. Also minus 1 here, minus 1 plus 1 is 0. It makes the whole of this become 0. But if you place in minus 1 here and here, none of this will turn to 0. Alright, so that means anywhere we have x, we'll just replace it with minus 1. So have 2 into minus 1 all square minus 7 equal to a into minus 1 minus 3 into, we have here to be minus 1 again, plus 2, and then plus b into minus 1 plus 1, and we also have here to be minus 1 plus 2 plus c into minus 1 plus 1 into minus 1 minus 3. So whatever it is this we eventually evaluate to give, it will be 0. Minus 1 plus 1 is 0, and here we have minus 1 plus 2. The result of this will be 1. 0 times 1 is 0. 0 times b is 0. So this will go. Similarly, when this becomes 0, the whole of this will go. So what you have left is minus 1 squared is 1. 2 times 1 is 2. And 2 minus 7 will give, okay, let's write it down. This will give us 2 minus 7 equals, and here we have a into, we have this to be minus 4, and then minus 1 plus 2 we just give 1. So what is the next thing we need to do? Is to multiply this together. Here will give us minus 5, and here will give us minus 4a. If minus 1 times 1, minus 4 times 1 will give us minus 4 times a is minus 4. So you divide both sides by minus 4 because you're looking for a, and when you do that, you will notice that minus 4 minus 4 will cancel out. Minus will cancel out with minus. Therefore, a is equal to 5 over 4. Alright, so we're not concerned whether it is a proper fraction or improper fraction. Those are not really necessary in this at this point. So the next thing we need to do again is to eliminate a and c so that we can get b. And how can we do that? Is also the same method we use for that of a. We're going to look for, since we want to eliminate this a and c, then look for something that is common in between or between this a and c. You can notice that x minus 3 are common. So because they are common, you can substitute x for 3, and 3 minus 3 will give you 0. 3 minus 3 will give you 0. And here, if you put in 3 for x, none of them will evaluate to give 0. So that means when x is equal to 3, so wherever you see x in this expression, you can replace it with 3. So we then have 2 into 3 all squared minus 7. This will be equals, we have a into 3 minus 3, and then we have 3 plus 2, and then similarly we have b into 3 plus 1 and then we have also 3 plus 2 plus c into 3 plus 1 into 3 minus 3. Of course, 3 minus 3 is 0, and that affects the whole of this to give you 0. Also, 3 minus 3 here is 0, and that will affect the whole of this. So what do we need to do? 3 squared will give us 9, and 2 times 9 is 18. 18 minus 7 will remain on the left hand side. On the right hand side, we have b into 3 plus 1, that is 4. 3 plus 2, that is 5. And 4 times 5, that is 20. We have that to be 20. So 18 minus 7 we give 11. So 11 will be equal to 20 multiplied by b will be 20b. Because we are looking for b, we divide both sides by 20, and 20 will cancel out, so that b will be equal to 11 over 20. So the last part of this problem is to make an assumption for x. What is the value that will be replaced with x to make sure we eliminate a and b? This time we want to look for c, and because we want to look for c, we need to eliminate a and b. Alright, so what essentially, when you look into a and b, what is common? We notice that x plus 2 and x plus 2 are common. Because they are common, if you replace x with minus 2, it will make sure that these 2 cancels out. So we then say when x is minus 2, when x is equal to minus 2, from that equation or from that expression, we will have, anywhere we see x, we just replace it with minus 2. So we have 2 into minus 2 all squared minus 7 will be equal to, so what do we have next? Anywhere we see x, we replace it with minus 2. So we have a into, what do we have there? Minus 2 minus 3 plus, okay, we have another term there also, minus 2 plus 2 plus b into, what do we have for b? We have x plus 1 and x plus 2. So we replace the x with minus 2 plus 1 and minus 2, what do we have there? Plus 2. And then the last one is for c. And what are the terms we have for c? We have x plus 1 and x minus 3. So we have minus 2 plus 1 and minus 2 minus 3. Alright. So keep in mind we want to eliminate a and b. So you can notice, if you notice minus 2 plus 2, this will give us 0. That means the whole of this will go. And also minus 2 plus 2 will give you 0, and the whole of this will go. So we have this to be minus 2 squared will give 4, and 2 times 4 will give 8, and 8 minus 7 will be 1. This will be equal to, on this part, we have minus 2 plus 1 to be minus 1. And minus 2 minus 3 will give minus 5. And minus 5 multiplied by minus 1 will give just 5. So we have here to be 5 multiplied by c will be 5c. So when you divide both sides by 5, this will cancel out. Therefore, c will be equal to 1 over 5. So now we've gotten the values of a, b, and c. So what is the next thing we need to do? Now the next thing to do is to bring out the values of a, b, and c. Keep in mind that what you have for a, the value for a was 5 over 4, and that for b, we had the value for b to be 11 over 20, and then the value we had for c was 1 over 5. Alright, so what we need to do is to put this into the equation. Remember where you assign a, b, c to these problems when we started solving, and this is a point. So wherever you see a, you can just fix the values you have for a, b, and c. So we then have 2x squared minus 7 all over x plus 1, x minus 3, x plus 2. Alright, the whole of this is equal to, what is the value for a? A is 5 over 4 all over x plus 1. What about b? We have 11 over 20 all over x minus 3. And then for c, we have 1 over 5 all over x plus 2. So the final point is to make sure that this denominators comes back here. So if you move them downwards, you have 4 into x plus 1 plus 11 all over 20 into x minus 3 plus 1 all over 5 into x plus 2. So this becomes the partial fraction to this particular fraction. We've resolved this to partial fraction. I hope you found this helpful, and if you do, please hit the subscribe button and like this video. And if you're new to this channel, consider subscribing to my YouTube channel. Thank you for watching. See you in the next video.